Hi everyone, my name is Rue, and in this presentation I'm going to talk about testing and doing test automation for Unity games and apps. Just a little bit about myself. I started as a tester in 2002, and I'm working as a software tester, but I'm also the managing partner at Altom. We're a company originally from Romania. We started in 2008, but nowadays we also have offices in Finland, in Helsinki, where I'm currently based. We do mainly software testing services and software testing training, but lately we've also been developing tools that help us with test automation and just make our work more efficient in the software testing world. As my own experience, I have done a lot of mobile testing and mobile development as well, a lot of automation in the mobile world. And lately, I have been focusing a lot on game testing, game automation, as well as game development, and doing all that specifically within the Unity ecosystem. My talk from today is based on my experience on two main projects. The first one is a project with Bitbar, which is a company originally from Helsinki, Finland, which is how I got to work with them. They offer a service called Bitbar Cloud, which gives you access to iOS and Android devices in the cloud. It's similar to AWS Device Cloud and Device Farm and Browser Stack, and there are a few others out there. The idea is that you can use their service to install your app or your game on hundreds of iOS and Android devices and either perform exploratory testing manually by interacting with your app or by running automated tests. So this was my first introduction to the game world, because I worked with one of their customers to try to help them build an automation framework that will let them test their mobile game in the devices that they had in the cloud. And then my second main project, I'm still working with the same team at the moment, was for a concept development team. We were using Unity for fast prototyping of different apps and user interfaces, and we had to support many different screens and technologies and platforms. So Unity was a good choice, even though we were developing apps, mainly because of its fast prototyping capabilities and multi-platform support. So kind of based on these two projects, I started using Unity more and more, and I started also using it for my hobby projects, but then also in Altom we started working with developing tools around the Unity testing capabilities. So in the last few years we had quite a few projects working with game development companies and helping them build their automation or improve their testing strategy. Thinking back to the first project, the Bitbar customer, they were a worldwide, very successful mobile company and mobile game development company. So they had quite a significantly large testing team, but they were struggling with a few challenges that I have then found to be very similar to other game development companies. First of all, since they were on mobile, they had a problem with the fragmentation that still exists in the mobile world. You have, especially if you're a global company, you have a lot of devices to cover and a lot of combinations of them, either whether it's based on the operating system. Android has still a very significantly slow adoption rate for the latest operating system, so you still have to test your game with old Android systems and make sure that it works. But also different combinations of screen resolutions. In the game world, screen real estate is really important, and you need to make sure that your game looks good on big screens and also shows all the graphics and all the needed elements on very small screens. So trying to test all of these combinations was really painful and time-consuming for a team of testers. Another aspect that was challenging with a non-automated approach was doing regression testing on all functionalities of the game. This is also quite a little bit different from the native world, because apps are typically very targeted. They offer a solution to a specific problem, so the app is not necessarily very complex. Of course, that's not true for all apps, but a majority of them are very focused on one aspect or one problem to solve, while games are generally extremely complex. They can have really huge worlds with different ways to play the game and a lot of randomness built into the game. So trying to cover all the functionalities for a game when a new significant change comes in can be very, very challenging doing all the testing manually, and it can become very time consuming. Another thing that I think is specific to Unity or game engine developed apps and games is the fact that, yes, you do have the multi-platform support, and that helps in terms of development, but in terms of testing, you still need to check that your game works on all the platforms that are covered with a single code base. So that's another challenge that was making testing difficult in general for the customer that I started working with. So they were looking for a solution that would help them basically install the game on as many devices as possible to cover a lot of the fragmentation problem, and then do some functional testing to make sure that the game works, performs well on different devices, and so on. And then eventually they wanted to do more complex testing functionalities and doing regression testing for maybe a smaller set of devices, but with a lot more coverage in terms of gameplay and levels and menus and so on. When I started working with them, the first thing I wanted to do was check what Unity had to offer. So I started looking at Unity Test Framework. It's the framework that they offer within the Unity editor for basically unit testing and integration testing. It's a very good framework. You can write your tests in C# and use NUnit for it. And it's great for testing individual units, game objects or characters and so on, and the integration between them. So it's, for example, excellent for a situation where you'd want to test that your player cannot go past an obstacle. So you would instantiate the obstacle, you instantiate the player, you try to move programmatically the player to some coordinates that are past the obstacle, and you would assert that that hasn't happened. So both maybe at the unit level of the player and the obstacle, but also the integration between them. They also have a play mode where you can test your game, maybe even load a scene on a target platform. But this kind of testing you couldn't do. So it's very Unity ecosystem specific. You run those from the Unity editor, but you couldn't be able to run them, for example, in a cloud like the AWS device farm and install the game and run these play mode tests on any as many devices as you want. At the moment, I think they support PC and mobile as the target platform, but not any platform and not in any condition. And it's still not the kind of the exported game that you would maybe use in production installed on a target device and tested from a user point of view. So this is the kind of testing that I think the company that I worked with through Bitbar was looking for, and this is the kind of testing that I'm used to coming from a web or PC or mobile testing world. The name I use for this is UI-driven automation, and I want to explain it a little bit just to make sure we have the same understanding of the concepts that I'm discussing. So if we think in terms of a Unity game, this is one of their sample scene, and it's a endless runner. You have the cat there that once the game starts, it's going to start running faster and faster, and it's going to try to avoid the obstacles that are on the screen. So on the left side there, we see the what's the so-called Unity hierarchy of elements of game objects. When I say user interface UI-driven automation, I don't just mean the UI level of elements or the UI canvas that Unity has that, for example, here I think probably contains the score and the buttons and the text. That's the menu that comes on top of the game. But basically interacting with the game in the same manner that the user would. This is what I mean by UI-driven automation. So that would mean interacting with these game elements here in the hierarchy, and trying to use them the same way the user would. I would try to move the cat left and right. I would try to jump the same way the user would to avoid obstacles. And at the same time, once the cat hits an obstacle, I would check that the live game object that we see there in the hierarchy, that probably has 3 children representing the 3 hearts, now only has 2 hearts enabled because the cat has lost 1 life. So interacting with the game in the same way the user would, or the same way the user would see things happening on screen, would be the goal when you think about UI-driven test automation to verify game functionalities. The go-to platform when we think about PC apps or mobile apps is Appium. It's an open source platform that supports iOS, Android, Mac, Windows, basically any programming language or scripting language. Also works with cloud services like Bitbar Cloud, BrowserStack, AWS Device Farm, and so on. And it's also using concepts and patterns that are very familiar to testers in general, because it's very similar to the way Selenium works, which is the most common framework for web automation. So when I started working with Bitbar, their customer was already trying to use Appium to install the game and interact with it in the cloud on the Bitbar cloud devices. Typically, when you work with Appium, you get an inspector similar to, you can inspect your application similar to the way we see the application here in AltUnity editor, and you can see the hierarchy of elements that you can interact with from a UI point of view. So the problem with using Unity or other game engines that just export the game for a specific platform is that they basically, when you try to inspect it with Appium, this is the Appium inspector window using an APK, so an Android version of the cat sample game. When you inspect it, the only thing you see is a view, a painted canvas. You don't see any of the other elements that we could see there in the hierarchy for the cat and the obstacles and the life and so on. And that's because none of the elements that Unity has within its own engine are exported as native objects. So if you try to use Appium for Unity games, you constantly just have this view that gets painted from within the Unity engine and displayed there. So the solution that, because you cannot find any of the elements, what the first solution that the customer tried to use was to basically just click at coordinates. So they would try to move the cat left and right and try to jump and interact with the game just by using Appium to click on the screen. And of course, especially since their first goal was to cover as many devices and many screen resolutions, clicking at coordinates is not a good idea because the coordinates always change. This is one problem with the click at coordinates approach. So you need to figure out a way to really identify where do I need to swipe or jump, or when to make sure that you actually make the cat jump or move. But the other problem is, not only you're not sure where to click or how to interact with the device, there's also no way for you to assert that your action, your click, your jump actually had the intended effect. So you don't know, has the cat actually moved? Has the cat died? You have no way of checking the screen or the elements that are within the game to make sure that your action was performed correctly. So my first approach when I started working with them, and my first approach in general to the game testing automation, was to use image recognition. And that solved, if we think about this, the problem that I explained with clicking at coordinates, solved both the problem of not knowing where to click, because we could find, let's say, the cat and click, starting from it to the right or starting from it to the left. So we could identify the correct coordinates on any screen size if we used image recognition. And we could also assert that indeed the cat has not yet died. Indeed, the cat is now on the right side or on the left side or jumping. So we would solve both knowing the right coordinates and being able to assert things within the game. And we started with this approach that we would define our elements using bits of a screenshot. So this is an example from The Sims. Well, Sims running on an Android phone. The house here, let's say that we would want to make sure that whenever the game starts for the first time in the tutorial, you are shown this default house element. So you could take that screenshot of it, the image on the left, and that would be our reference image from now on for the house. So whenever the game was loaded, we could verify that we're using image recognition. We even assert, we could find the exact coordinates of the house, but we could also assert that taking a screenshot from the device and running an algorithm, we could figure out whether the house is displayed on the screenshot or not. And the green rectangle there shows where the algorithm found the house within the screenshot. We used an algorithm that was resolution agnostic and worked on items that were at a different angle and maybe even hidden under things, because it wasn't doing pixel by pixel comparison. In this slide, this is the exact screenshot that we took the reference image from. So of course, if we compare pixel by pixel, we would find the exact image within the larger screenshot from the game. But if we think of an image like this, where we're trying to find the cookie box in a big pile of objects where it's partly hidden by the rice box, we need a different type of algorithm. Matching pixel by pixel wouldn't work because we wouldn't find the same pixels in the bigger image. So this feature detection looks at features of a pixel in the reference image, or like their properties, and then tries to find a pixel with the same features or properties in the bigger image. And when it finds enough of them, it can make an assumption that, okay, the rectangle must be in that position there as shown in green, even though it's partly hidden by the rice box. So this allowed us, continuing with the Sims example, to do tests like not just the exact image, but also, rotated, totally different angle in 3D, zoomed in, and so on. For example, in this case, the sim is no longer in the house. The house is there's a lot more light in it, and so on, but still the algorithm finds the approximate shape where the house exists on the screen. And we can assert that, yes, the game is still displaying this house. So this solution allowed us to define a set of game elements by defining little reference images, and use image recognition in our automated script to interact with the game with correct coordinates, and also assert that the game reacts to stuff very well. We open sourced this and it's still available from Bitbar on their GitHub account. So in terms of usability or utility, it worked really, really well for simple scenarios. We were able to write Java and Python automated scripts that used Appium to install the game and interact with the operating system, with the device, and alongside use the image recognition algorithm to test, for example, the first few steps of a tutorial, or make sure that the game indeed loaded and was still running even on low-end resolution phones or phones with low specifications in general. So we found a lot of really useful issues like out-of-memory problems. We were able to basically install the game and run the tests on 300 devices at the same time and come up with crashes or graphics missing or not being displayed, or phones that didn't have enough memory to run the game, and so on. And this allowed the customer to be able to say, okay, these phones we don't support, so we're going to take them out of the list of of supported devices from the Play stores. And it allowed them to also very quickly react whether they knew this phone was particularly popular in an area, to try to support it by improving their memory consumption and things like this. Or fixing crashes. We would find crashes very easily because the game would no longer be running, and image recognition would immediately notice that, okay, it doesn't find the right elements on the screen. On the other hand, this approach was not fast enough for a lot of games. It was good enough for this kind of like action-driven, you click and something happens in the game. But for an example like the Endless Runner that I was showing earlier, where the cat runs automatically faster and faster, image recognition was not fast enough to react to that. Another thing that happened was it didn't work well for, it didn't give us enough granularity. If we think back, if we look back at this specific example, yes, the house is still discovered there, but what if you wanted to check that it's in the exact same position? We couldn't really do that. Or what if we wanted to check whether the sim is inside the house or not? This didn't give us the level of granularity that we needed to identify elements very precisely. And it also, another problem that was clear very, very soon was that graphics in games are something that change all the time. It's one of the things that we constantly improve when we are developing a game. So we had to constantly redo our reference images, take screenshots from the device and redefine what is the house, what is the sim, what is the cat. So this maintenance work was very time consuming. So in the long run, it was very difficult to keep our automated scripts up to date. So because of these drawbacks of the image recognition approach, I realized that what I needed was a different approach that would give us more granularity, would not depend so much on the actual graphic changes, and that would be a lot faster than the image recognition was, so that we could support a larger variety of games and include games that are fast-paced and where the response times are really important. So we had to find something going beyond image recognition. If we look back at this example with the cat and the Endless Runner in the Unity editor, what I really wanted was to have access from a script to all of these elements in the hierarchy. I wanted to know what elements are available and active currently in the scene and how can I interact with them. And I wanted to be able to get information about their properties. Does the life still have 3 children? Which means the cat still has 3 lives. Is the cat on the left lane or on the middle lane or on the right lane? Being able to get these properties and interact with them would give me enough control to be able to do test automation in a UI-driven fashion with a lot of confidence and with a lot of speed. I started working on a solution that would really just insert a prefab within the Unity scene or Unity level, let's say, game level, that would constantly know the status of the elements in the game and would also listen to commands and could tell me information about the game objects and their properties in real time. At first, this was just a tool I worked on, but then we started developing it further within Altum, and other people joined me within our team, and we called it AltUnityTester. It's now an open source tool, and I'll tell a little bit about it and how it helped us in our approach to doing UI-driven automation. So it's basically, like I said, it's a prefab that we add to the game that's included in every scene or in every level of the game that listens to commands on a specific port. So we wrote the first version in Python. So it would simply start what we call a driver for the game. And then it would wait for commands like, what's the current scene? Wait for it to be home. Can you find the bed? Yes, the bed element is within the scene. Can you tap on it? And the tapping would happen with Appium. This was kind of the first version of the tool that worked really well to help us build the first automated tests. It would still support Appium. It would use Appium basically to interact with the phone, so we could still use it in the cloud. But we kind of built around it a whole framework with different methods of querying the elements, interacting with them, and also getting their properties and setting their properties whenever possible, whenever those properties were publicly exposed within the code. So we decided to open source it. Which was a really good idea because we learned a lot. First of all, we learned that we this is a problem. People started using the tool right away, which meant this was a problem that others were trying to solve and that others were looking for a solution for. So we had quite a fast adoption rate, but we also had at the same time a lot of feedback on how to improve it, what to add, and how to expand the support for it with platforms and so on. So we very soon added support for Java and C#. And we also added a Unity editor window similar to the Unity test runner to kind of help with the people that are comfortable within the Unity editor and within the Unity ecosystem to also be able to write this type of end-to-end automated tests. We've been developing it now for quite a long time. We keep adding new features and trying to support new platforms. We originally only supported mobile platforms, but now we support PC as well, and we're working on console support. And it should be pretty easy to add new platforms because all we do is open a socket within the game that the tests connect to. So any platform that would support a TCP connection should be able to support AltUnity Tester as well. In terms of the approach, in comparison to the image recognition approach that was slow and didn't give enough granularity, AltUnity Tester offers a really fast way of doing automation. It has, as far as we have seen, it has zero impact on the performance of the game, and we're able to basically in real time identify objects and say, okay, for example, with the Endless Runner game that I showed, once it's the game is in progress and running on a target device, we are able in real time to check what objects are coming towards it, and this is a random algorithm. We can check, is it a trash can? Yes, then we cannot jump over it, we need to move left. We're able to do all this logic in real time and still react to fast enough to play the game via this AltUnity Tester solution, which is great because it means we can support a large variety of games. Of course, the games that are driven by user events are also supported. It also gave us the capability to assert on anything. We could anything that's available within the Unity scene. So we don't only have access to whatever is seen on the screen by an algorithm with image recognition. We can check the status of objects. We can see that the tree contains or the hierarchy contains everything that we expect it to contain at any moment, and we can even see the properties of different game objects within a level. So using AltUnity Tester allowed us to test not only simple scenarios like with the image recognition, but it also allowed us to do functional testing, regression testing. We could have quite complex scenarios tested from an automated environment and using automated scripts. At the same time, because we can also access some functionalities that are only available programmatically, it allowed us to maybe control the randomness of the game or do a bit of both worlds, do a bit of the integration testing that you can do with the Unity test framework, but also to set up your game or set it into a specific state and then still do UI-driven end-to-end automation using the scripts. So from an approach point of view, we found AltUnity Tester really, really useful. And we also got feedback from others that they have found it useful and it does answer the needs that they had before when trying to do automation for Unity games. Since we started developing this tool, we also worked with quite a few companies trying to help them with their testing needs in general for games and with automation specifically. And having now the experience of two approaches, doing image recognition and doing this kind of object identification and interaction approach, we realized that companies are very interested in this and think that they would really want to use it. Working with different clients, we noticed two different types of challenges in general with adopting any kind of UI automation in games. And the first one is a very simple one. A lot of the teams that we've met and talked to are very small. A lot of games are developed by 1 to 3 developers that spend all their time doing development tasks, and the testing that they do is by playing the game themselves, and they don't have the time to invest in automated tests. So trying to help those teams, we're trying to stay as close as possible to the Unity development environment, the Unity editor, and try to make running these tests within the editor very easy, and try to encourage people to see the value of writing simple functional tests, just to make sure your changes haven't broken anything, and run them as you develop the game. So we try to focus on helping developers do their work more efficiently and get faster feedback to anything that might have broken in the game in terms of functionality. At the other end, we have game development teams that are very large, and in consequence they also have large testing teams. But most of these teams are composed of manual testers, or testers doing only exploratory manual testing and no automation. And even though testing manually all the functionalities and doing regression using, even though it's a large team, it's still time consuming. And even though these teams would really benefit from using a tool like Unity Tester or doing UI driven automation, a big obstacle there is the fact that a lot of the testers that do the manual testing don't have coding experience, and they are not comfortable with doing scripted automated testing. So with these two types of teams in mind, we are currently trying to see if there's a way for us to make the teams more accessible to testers who are not coders, who don't have any programming experience, while at the same time keeping the development and the developers involved and engaged within both the tool development and the tool use. What we try to do is we have a Discord server nowadays where we offer support as much as possible for our users, and this also helps with testers that are not very comfortable or have maybe just a little bit of experience with test automation. We try to help them get started and answer any questions or strategy concerns that they might have, and we also try to keep a list of up-to-date examples to get people started and just to get them to understand how to configure different platforms, how to run multiplayer tests and interact with multiple devices at the same time. Another thing that we are working on at the moment, which is something that we plan to release hopefully by the end of the year, and we currently have in alpha, is what we call the AltUnity Inspector, which is a tool that kind of gives testers the opportunity to inspect the game and see the hierarchy of game objects, similarly to what the Appium Inspector offers for native apps. So for any game that's been instrumented with AltUnity testers, a tester could use the inspector to identify elements, see their properties, see what properties are changeable, see the coordinates of the objects on the screen. Using the inspectors, especially for testers that are not comfortable in the Unity editor or comfortable with looking at the code to discover properties of the objects, the Unity inspector gives them an easy way to find objects, see what's available to interact with in a scene, and also to find all the properties and all the methods that can be called or set from using Unity Tester, and from to write better UI automated tests. In conclusion, the two approaches that I've described, the image recognition and then the object identification that you get with AltUnity Tester, are both valid approaches to UI-driven automation for games, and we've seen each of these work better in certain cases and worse in others. However, our plan and our goal as a software testing company and as a developer of tools that help with UI-driven automation in games, what we're interested in is constant feedback. So my main goal with doing these presentations and going to conferences and talking about my own experiences and what the tools that we have developed to help us do our work better, my main goal there is to get to talk to other people that might be in similar situations or that might have problems similar to the ones that we've encountered, and to discuss what else we could do, how else we could improve, what else is missing from the set of tools that are available today on the market, what are their approaches, what's the best approach for different types of games. So talking to people, but also trying to learn about different types of games. The game world in general is so diverse, and there's so many different types of games that we're pretty sure that all the games that we've tried so far cover only a very little part of all the games that are available out there. So my main hope during this presentation is that if you've watched it, you will get in touch. If you are a developer, if you have testing needs that you think have been covered that are similar to the ones that I've described here, or if you have new ones, you'd get in touch and let us know what's your feedback. How did you solve these problems? Have you tried our tools? What did you think of them? How can we improve it? So my main goal is to start a conversation, and I'll try to be available on Discord as much as possible throughout the conference. But of course, I will be available also later on our Discord server, and you can find us using the links that I've shared in the presentation. So please come and talk to us. Give us feedback. Let's have a conversation about how you do testing for your game. Thank you very much.